Magnetism and electromagnetism. Question 4. The teacher used the equipment shown in the figure below to demonstrate the motor effect. Okay, so we've got horseshoe magnets. There's a magnet there, there's a north pole, there's a south pole, copper rod going through it, and that copper rod is connected to a variable resistor, to a battery, to a switch. Okay, so we can get a current flowing through that way. We know that that side is the negative, that's the positive, that's the negative, the small one's the negative. Okay, so we're going to get a current, we're going to electrons flow through there, we're going to get a current going from positive to negative. Okay? Question says, describe how Fleming's left-hand rule can be used to determine the direction in which the rod will move when the switch is closed, and state the direction. It's worth 4 marks. Okay, lots of people might miss that. State the direction there. 1, 2, 3, 4 marks. So describe how Fleming's left-hand rule can be used. Well, the first thing is we need to describe Fleming's left-hand rule. Now, I'm not going to try and draw a hand, but I will just draw 3 arrows. These indicate your different parts of your left hand. So we know that's the thumb. We know that's the forefinger. So index finger, sorry. This is your index. And this is your, which one's that one going to be called? Your second, third finger. Okay, so we've got those 3 things then. So I know that that one is an F, B, and I. So first of all, your thumb. So left hand. That's the left hand. Let's just make sure we're going to describe, put that into words. Left hand, thumb, index finger, and which finger is that? Third finger, all held at right angles to each other. That's the key bit. Now, the fact you've drawn a diagram actually will help explain that. It's quite a hard one to explain, but the fact you've drawn that diagram there, in particular, if you've drawn right angles, little right angle symbols like that, okay, that's going to help show that there are right angles between all 3 of those angles. So then we need to describe what's going on. So your index finger, so we need to state the direction. So we're going to try and find force. So index finger points from north to south along magnetic field. Okay, that last bullet's going to be for the direction, so I'm going to just I'm going to say what else happens here. So we've got the third finger points in direction of current. So we know here the current goes that way, so the current is going to be going this way. So I'm going to draw on my diagram. Use the symbol I. In fact, I might even draw B that way. Okay, I'm going to draw my diagram so that the examiner will be under no sort of no doubt that I know exactly what I'm doing here. So I've got those. The index finger points from north to south. Okay, I'm just going to index finger points from north to south that way. Current flows that way. So the thumb points in direction of force. Okay, so this tells me the rod will move upward. Okay, so using all those things, the the rod will move upwards. Okay, next one. Increasing the current can increase the force acting upon the copper rod. Give one other way in which the size of the force acting on the copper rod could be increased. So size of force on that rod can be increased. They've said increasing the current, so I can't have that. Okay, so it's only worth 1 mark. So what else could I do? Well, I could use a stronger magnetic field. A stronger magnet. Careful here not to say bigger. Okay, bigger magnets aren't necessarily stronger. Use a stronger magnet. Well, what would that do? That would have more lines of flux. Okay, or you could say a more dense B field, magnetic field. Okay, that would do the same thing. What else could I say? I could increase the length of the wire. So increase length of wire in the, I'm going to use the shorthand B field, okay, magnetic field. Okay, make sure it's got to be in the magnetic field. There's no point, the length of wire outside the magnetic field will have no effect at all. It's got to be inside that magnetic field to experience the force. And what's the easiest way of doing that? The easiest way is to coil the rod, coil the rod inside the B field. And that way every little piece, every individual coil would experience that force. Okay, hope that's useful.